we have conjugate surd. Conjugate surd. Okay, look at what is a conjugate surd. Now there are two surd. These are two surds whose product we give a rational number. So when you have two surd that if you multiply them together and they give you a rational number, not irrational, then that is how that is what we call a conjugate of a surd. E.g., conjugate of x minus y is x plus y. Is x plus y. So the only thing to do in a conjugate, if you want to find a conjugate of a set of 10, all you need to do is to change the sign to the opposite side. Right? If it is plus, it changes to minus. If it is minus, it changes to plus. So therefore, in general, the conjugate of root x plus root y is equals to root s minus root y. Conjugate of root x minus root y is root x plus root y. Okay, so this is how to find a conjugate of a set of surd. Then the next thing we have here is surd rationalization. Okay, how do you rationalize surd? I have already explained that earlier. This concern with the process of removing irrational number. It concerns with the product of removing irrational number from the denominator. So if you have a denominator, you can remove the rational number in that denominator. Consider the surd 2 over root 3, an irrational number dividing a rational number. Here, both the numerator and the denominator must be multiplied by root 3 for it to be removed. Okay, so if you want to rationalize a surd, the denominator, which is the root, you are going to use the same denominator to multiply by itself and then multiply by the numerator. Look at the example here. We have example 1, simplify 2 all over 5 root 3. You see that the numerator is rational. The denominator has irrational part, which is root 3. Also 3 over root 3 plus root 2. Okay, 2 over 5 root 3 will be equals to, so we have to use the irrational part. We have to use the irrational part to multiply both the numerator and the denominator. So the irrational part here is root 3, which is going to be equals to 2 all over 5 root 3 times root 3 over root 3. So you use this to multiply both this and this. That's what we did here. So 2 times root 3 is 2 root 3 all over 5 times root 3 is 3 times 3 will give us 9, so we have 5 root 9. So therefore, if this is the case, then we have 2 root 3 all over square root of 9 is 3. Okay, so this is the same thing as equals to 2 root 3 all over 5 times 3 is 15. So we have solved this. So we discover that the denominator is now a rational number. It's no longer having square root. Then the B part, 3 over square root of 3 plus root 2. Now, for us to find this kind of, to solve this kind of problem, you have two sets. You can discover that you have two sets of surd. So you using the conjugate of root 3 plus root 2. That is, the conjugate of root 3 plus root 2 is going to be root 3 minus root 2 to rationalize. So if you have a set of surd like this linked by plus or minus, if you want to rationalize it, you use the idea of conjugate. I've already explained that. Okay, you can look at for where I explain it. Alright, this is going to be equals to 3 over root 2 plus root 3, which we ought to have before, times, okay, the conjugate of this is root 3 minus root 2 all over root 3 minus root 3 minus root 2 all over root 3 minus root 2. If you multiply this, this 3 is going to multiply this and also multiply this at the same time, just like we are going to use it to open a bracket, multiply the 3 by each of the term. 3 times root 3 is 3 root 3 minus 3 times root 2 is 3 root 2. Okay, all over root 3 plus root 2 multiplied by root 3 minus root 2. So the numerator is what we repeat here. Okay, then the denominator we have to, open it now. Root 3 times root 3 is root 9. Root 3 times minus root 2 is minus root 6. Root 2, we are done with this root 3 now. We use this root 2 now. Root 2 times root 3 is plus root 6. Plus root 6 times minus root 2 plus root 2 times minus root 2 is minus root 4. So the numerator is what we bring down here. Then root 9, you discover that is 3. Square root of 9 is 3. Then minus root 6 plus root 6, they will cancel themselves out. It's going to be 0. If you are owing somebody root 6 and you get somebody dash you root 6, you know that you are going to get 0. There is 0. So minus root 6 plus root 6, they will cancel themselves out. It is now 0. So you are left with minus root 4. So square root of 4 is 2. So therefore, the numerator is what we represent here. Then 3 minus 2 is 1. So all of this numerator divided by 1 is still the same thing. 3 roots 3 minus 3 roots 2, which is the answer. Okay, so example 2, we have example 2 here. Evaluate 1 all over. Okay, evaluate 1 all over 1 minus root 3 all squared. Okay, then the B is 2 plus root 3 all over root 2 minus root 3. So this is the next thing we'll be looking at. This is example 2 that we'll be looking at. So 1 all over 1 minus root 3 all square is equals to, we have to expand this. Okay, this is 2 brackets, we have to expand this. This is 1 all over 1 minus root 3 and then 1 minus root 3. So by the time you open this bracket, 1 times 1 is 1, minus root 3 times 1 is minus root 3. Then, 1 times 1 is 1. 1 times minus root 3 is minus root 3. Then minus root 3 times 1 is minus root 3. Then minus root 3 times minus root 3, it will be plus root 9, because minus times minus is plus. So this is going to be equals to, we have 1 all over 1 is what we bring down here, minus root 3 minus root 3 will give us 2 root 3. 2 root 3, because 2 of them is there, minus 2 root 3. Then square root of 9 is 3. Square root of 9 is 3. Okay, this is equals to 1 over, this is 1. We have 1 here. This 1 plus this 3, because they are rational. 1 plus 3 is 4. Then minus 2 root 3. Minus 2 root 3. So this is what we have. So now that we have this now, in our denominator, we don't want to see square root. So we have to remove it. So the process of removing it is to rationalize. Alright, to rationalize. To rationalize means we need to use the conjugate of this. Conjugate of 4 minus 2 root 3 is 4 plus 2 root 3. So this is the same thing as equals to 1. The conjugate is, we use the conjugate to multiply by 4, which is 4 plus 2 root 3. There is a conjugate. The same thing here. The conjugate of this is 4 plus, is this one. So we are using the conjugate to rationalize. Rationalize means using this to multiply the numerator and the denominator. So all of these things times 1 is still the same thing as 4 plus 2 root 3. We open this bracket now. 4 times 4 is 16. Okay, then 4 times 2 root 3, because 4 times this 2 is 8, then root 3 is what we bring down here. Then minus 2 root 3 times 4 is minus 8 root 3, because 4 times 2 is 8. It's 8. Okay, so the minus times this plus is this minus. Then we have 2 times this 2 is this 4. Then root 3 times root 3 is root 9. Okay, so we have 4 plus 2 root 3, which is in the numerator. We discover that this is 16. So we bring the 16 down. We have 8 root 3 minus 8 root 3 is 0 already. So minus this 4 is what we bring down here. Square root of 9 is 3. So therefore, we have 4 plus 2 root 3. 16 minus 16 is what we bring down minus. 4 times 3 is 12. Okay, so we have 4 plus 2 root 3. 4 plus 2 root 3 all over 16 minus 12 is 4. Okay, so this 4, you can split it for 4 and 2 root 3. So therefore, 4 divided by this 4 will give us 1. Then 2 here is 1. 2 cancel itself. And then 2 into 4 is 2. So we have 1 over 2 root 3. So this is going to be the answer to this particular problem that we have solved. Example B, the B part, we have 2 plus root 3 all over root 2 minus root 3. Okay, so if we are solving this, we need to, find the conjugate of the denominator, then use the conjugate to multiply the numerator and the denominator at the same time. So the conjugate of root 2 minus root 3 is root 2 plus root 3. This is going to be equals to the whole of the numerator, which is 2 plus root 3, multiplied by the conjugate, which is root 2 plus root 3, all over the denominator is root 2 minus root 3, multiplied by the conjugate, which is root 2 plus root 3. Okay, so if you open this bracket, 2 times root 2 will give us 2 root 2, and 2 times plus root 3 will give us 2 root 3. We are done with these two. Then root 3 times root 2 will give us root 6, plus 2 times 2, 3 times 2 is 6. All right, and then root 3 times root 3 will give us 3. Why is it 3? Because 3 times 3 is 9, and then the root of 9 is 3. Then all over root 2 times root 2 will give us 2. Why is it 2? Because 2 times 2 is 4. Then the root of 4 is 2. Plus root 2 times root 3 will give us root 6. Minus root 3 times root 2 will give us minus root 6. Then minus times this plus will give us minus. Root 3 times root 3 will give us 3 times 3 will be 9, and then root of 9 is going to be 3. So therefore, if you go up here, you discover that we have root 2 plus root 3 plus root 6 plus 3, which is the numerator, all over the denominator. You discover that this particular 2 minus 3 will give us minus 1, then plus root 6 minus root 6 is 0. It has gone already. So all of this, all over minus 1. So this minus 1, if you divide this by minus 1, is the same thing as minus 1 into bracket of all of what we have as the denominator, as the numerator. So that is what we are going to have there. All right, so example 3, express 14 minus 8 root 60 all over 6 root 20 minus 10 root 12 in the form of a root 5 plus b root 3. So where a and b are rational numbers, a and b are rational numbers. So by the time you solve this problem, your answer should look like this. That is what they mean. Okay, so let's solve it together. This is the question. Of course, we have to, find the conjugate of the denominator, and the conjugate of 6 root 20 minus 10 root 12 is going to be 6 root 20 plus 10 root 12. This is the conjugate. This is the conjugate here. So if we have this as a conjugate, then what we are going to have is you multiply the conjugate by the numerator and the denominator. So therefore, this is the numerator which we brought here, multiplied by the conjugate. This is the denominator multiplied by its conjugate. So we have to open up this bracket. So 14 times 6 root 20 is going to be 84 root 20. 14 times 6 will be 84. Then root 20 is what we attach to it. Then 14 times 10 root 12 is 140 root 12. Okay, because 14 times 10 is 140, then the root 12 is what is attached to it. Then we are done with 14. Then we go to minus 8 root 60. times 6 root 20. 8 times 6 is 48. Then 60 times 20 is 120. So that is why we have root 120. Then minus. Why? Because this minus times this plus is minus. So therefore, we are going to have my 8 root 60 times 10 root 12. 8 times 10 is 80. Then 60 times 12, press your calculator and see, it's going to give you 720. Then in square root, in root. Then the same thing goes for the denominator. We expand. Multiply 6 root 20 times 6 root 20. You discover that 20 times 20 will give you 400. Root of 400 will give you 20. Of course, 6 times 6, what will give you multiplied by that 20 will give you 720. All right, so I have to omit the in-between values. Of course, if you follow this video, you should be able to expand this. So pause this video and expand this denominator to be able to get this. If you cannot get it, go back and see how I expand, do the expansion from the previous example. All right, so okay, so now if we have this, then we continue with this evaluation. Now we have all of this numerator repeated here. Okay, but before then, you see this is 84 times root of 20 can be simplified further. 4 times 5 will still give us 20, so root of 4 will give us 2. So that is why we have 2 here. Okay, so plus we have 140. This is the 140 times 12 can be simplified into 4 times 3. 4 times 3, so root of 4 is 2, so that's why this 2 is here. Then the 3 is irrational, so is here. Minus 48 times 120, of course, we do the same thing. Minus 80 into multiply by 12 times 12 root 5. You have to simplify. I've done video on simplification, so you can check it up if you don't know how that is gotten. So 84 times 2 root 5 is this particular value. Then plus 140 times 2. 140 times 2 is giving us 28 this 80 root 3. Then minus 48 times 20, 960 root 3. 80 times 12 give us 960 root 5. Okay, so now that we have this, we discover that this is root 5, this is root 3, this is root 3, this is root 5. So those ones that have the same root, we discover that we can treat them. So 168 root 5 minus 96 root 5 will give us minus 792 root 5. Okay, and then 280 root 3 minus 96 root 3 will give us 680 root 3. Okay, so like before, I've explained this. If we have the same root or irrational values such as this, if they are the same, pick one of them and then the rational part of them, operate with the rational part of them. Okay, so now the next thing is we have this minus this all over this already. So this is the denominator. The denominator here, which is minus 480. Minus 480 is belonging to this and also belongs to this. So by the time you split it, you discover that if you reduce it to the lowest term with this and with this, you have 33 over 20. Here, this minus and this take care of the minus of this, so here become positive. Then here is also minus. This minus take care of this minus, here become positive. And if this goes into this, if you reduce them to the lowest term, you have 17 over 12 root 3 and root 5. So you discover that our answer is in form of a root 5 plus b root 3. They ask us to leave our answer like that. Okay, a root 5 plus b root 3. Okay, so in that question we have root 5 and root 3, and then the rational part that is outside, they are the a and the b, which is look at them here. 33 over 20 is the a, 17 over 12 is the b.